When you are looking at older Bobcat skid steers that have 3-digit model numbers without a letter prefix or suffix, in general, the first digit tells you the frame size of the machine, ranging from 3 to 9. The second digit tells you the generation, ranging from 1 to 8, and the third digit tells you about the engine. It should be a 0 for air-cooled gasoline-powered, a 1 for air-cooled diesel-powered, a 2 for liquid-cooled gas, and a 3 for liquid-cooled diesel. Now, there are a significant number of machines that don't follow that naming convention, even though it seems like they should, but most of them do. So hopefully, if you just come across an old Bobcat that you don't know anything else about but the model number, that will be a good starting point. Also, while I'm thinking about it, you will commonly see these Advantage Series stickers on Bobcats of this era. These are largely meaningless. They're really just an advertising tool that Bobcat employed to try to help popularize the idea of using a skid steer loader and mini excavator combination in place of, say, a singular tractor loader backhoe machine. The idea was that if you had that combination, you had the Bobcat advantage. There is in fact zero physical difference between so-called Advantage Series machines and regular machines, other than this nice bumper sticker that Bobcat put on them. But anyway, this is a Bobcat 873G series skid steer loader. Bobcat introduced the 873G in 1999 as a replacement for the 873F. The F and G series can be easily distinguished by a couple of obvious differences. For one, where the ROP structure on the G series has a more rounded off design and unitized construction, the ROPs on the F series is very square and is more obviously fabricated out of multiple assemblies. Additionally, the headlights on the G series are triangular and recessed into the corners of the ROPs, whereas on the F series the headlights are rectangular and they're not recessed, they just kind of hang down in the corners of the ROPs in about the same spot. Also on the G series, where this part of the boom linkage has a bend in it, on the F series that linkage is straight. There are a few other more subtle differences, but by far the most straightforward way to tell is to look for the data plate, which should be underneath the lift arm on the left-hand side, and close by should be a sticker that tells you what series it is. This one is not very legible, but hopefully you can make out it's supposed to say G series. The data plate has, of course, the model number there, 873, and a serial number or product identification number. The first 4 digits of that number can be decoded into the model and engine combination, and then the last 5 digits are the actual sequence of the particular machine in the production run, starting at 11,001. So that would make this something like, I don't know, the 35,000th 873 built, or something like that. The 873G was produced until 2002, when it was replaced by the S250. Coincidentally, there happens to be an S250 sitting right here. As you can see, they look pretty similar, with the boom design being the most obvious difference, especially this curved portion at the back. And you can also see where the boom arms sort of come towards the middle of the machine at the front and have these large flat areas that the 873 does not have. I was going to kind of rattle off some physical specifications for this machine, but I think it will be better to just post some pictures of the spec sheet out of the service manual so you can reference it as needed. Another thing worth noting is that the operating weight given is with full fluids, a construction/industrial bucket, which is like the standard bucket, and a standard operator. They don't actually list a weight for that, but I would assume about 150 to 200 pounds would probably be a safe bet. I'd also like to point out that this particular machine is a little bit wider than it should be because it has wheel spacers for running over the tire tracks on it. So normally the wheels and tires would be a little bit closer to the frame. Seated in the operator's position, I can show you the controls and instrumentation. In the left-hand corner, we have the engine temperature gauge, the hour meter, which also serves as a glow plug countdown timer, and displays error codes when prompted. The fuel gauge, the headlight button, press once for front lights only, twice for front and rear. The bucket positioning switch, which you can push to activate bucket auto leveling if equipped. The high flow hydraulic switch, which you push to activate high flow hydraulics. The standard auxiliary hydraulic switch, push once for variable flow, push again for maximum flow. And the auxiliary pressure release switch, which you press and hold to shut the engine off and relieve auxiliary hydraulic pressure from the couplers. This green switch here should say press to operate loader. It's worn off, but with the lap bar down, if you press that, these three lights should light up indicating that the lap bar is down. The solenoids to unlock the lift and tilt spools in the valve body are activated, and the solenoid to release the parking brake is also activated. And the parking brake can only be released if the computer detects that the engine is running. Lastly, on this side, we have the traction lock override button. With the lap bar up, if you push that, it will release the parking brake, and that's used if you need to move the machine around without actually being in it. For example, if you're using a backhoe. Here in the middle, we have a row of rocker switches. This one on the end is for selecting between hand and foot or hand-only controls if equipped. This one is not used for anything. This one is for activating the power bob attach if equipped. This is the parking brake switch. And then we have switches for turn signals, hazard flashers, and a rotating light beacon on top if equipped. Depending on the serial number of your machine, this switch panel may look different. It may have the switches mounted horizontally instead of vertically, and it may have their positions changed a little bit as well. If in doubt, you really can't mess anything up by just flipping the switch with the machine sitting still. In the upper right-hand corner of the cab, we have the right-hand control panel. It has a series of warning lights in this screen here. I'll try to just put up a picture of those. That'll make it easier to see what they are and what they mean. But other than that, the only thing on this panel is a key switch with 3 positions for stop, run, which is also preheat, and start. Now this is the standard control panel. There is also a deluxe control panel. The main difference is that in place of the key switch, it has a membrane pad numbered 0 through 9 for inputting a code to start the machine, and above that it has an LCD screen to display a whole bunch of different stuff. I think like real-time engine parameters and like job timers and a bunch of other stuff I'm not even really sure about. If your machine is equipped with a cab with heat and air conditioning, it should have an additional control panel over your left shoulder. There should be a 12-volt power outlet, an empty slot, a switch for front windshield wiper and rear windshield wiper if equipped, 2 more empty slots, a knob for fan speed control, a switch to turn the air conditioning off and on, and a knob for temperature control. This is actually in that S250 that I just showed you, but it should be exactly the same in the 873, I believe. Also in the cab, you will see 2 joysticks, one on the left and right, and 2 foot pedals, also on the left and right. This machine is equipped with standard hand and foot controls, so pushing the right hand joystick forward causes the right side wheels to rotate forward, pulling it back causes them to rotate backwards. Exactly the same thing on the left side, forwards and backwards. The boom is controlled by the foot pedals. Pushing forward with your toes on the left hand pedal will cause the boom to lower. Pushing forward on it more will lock the pedal into a detent position for float. Pushing down with your heel will raise the boom. Pushing forward with your toes on the right-hand pedal will cause the bucket to dump, and pushing down with your heel will cause it to roll back. There were 2 other control schemes offered on the 873G. Bobcat refers to them as Advanced Hand Controls, or AHC, and Advanced Control System, or ACS. In both cases, the drive controls are exactly the same. Push the sticks forwards and backwards to control the wheels on each respective side. But with advanced hand controls, the boom and bucket are controlled by tilting the sticks in and out or left and right relative to the machine. So on a hand-controlled machine, to raise the boom, you would tilt the left-hand stick away from you, and to lower it, you would tilt it towards you, and then to lock it into float, you would just pull it towards you until it goes over the detent and locks into the float position. Also, many hand-controlled machines, both AHC and ACS, were equipped with push-button float, as shown here. In this case, to activate float, you press and hold the float button, and then while holding the boom control in the lower position, you release the float button. And then to deactivate float, you just either raise the boom or push the float button again. Correspondingly, to dump the bucket, you would tilt the right hand control stick away from you, and to curl it back, you would tilt it towards you. Advanced Control System, or ACS controls, are identical to that, except there should be a switch up here on this control panel, like I mentioned earlier, that allows you to switch between just hand controls or hand and foot controls. So with advanced hand controls, which are hand control only, the pedals are fixed in place and don't do anything other than provide a place to rest your feet. But with ACS controls, there will be electronic sensors on each pedal that detect their position and relate it to actuators on the hydraulic valve for the boom and bucket. And it will be immediately obvious if your machine is equipped with either of these options, because the control sticks will look completely different. Instead of being a small metal tube like these are, they'll be like a big boxy square looking thing, and that is to contain the electronic sensors that detect the handle position and also the hinge mechanism, which allows them to pivot. Also, on earlier machines, instead of a switch activated parking brake, there may be a pedal mounted right where these 3 bolts are. The 873G was also available with a 2-speed travel option that is controlled by this switch on the right side of the right hand control stick. Pushing it up activates high speed, and pushing it down is low speed. The auxiliary hydraulics on the 873 are controlled by this thumb switch on the right hand stick. As you can see, it is bi-directional, and when set to variable flow, the amount of flow corresponds to how far you push it in either direction. This switch on the left side is used to control electrically controlled attachments, and this trigger on the front of the control handle is used to control continuous auxiliary hydraulic flow by pressing it on and off. And continuous flow in reverse can be activated by holding the thumb switch to the left and then pressing the trigger. These switches on the left-hand control stick are also used to control electrically controlled attachments, and this thumb switch on it controls the rear auxiliary hydraulics and the front secondary auxiliary hydraulics. Those both receive their fluid from the same circuit, so if your machine is equipped with both and you only want to use one at a time, you can only have one or the other hooked up at a time. The only other controls in the cab are the throttle here, back for slow, forward for fast, and the emergency boom release, which is this square red knob here. Turning it clockwise and pulling up on it will release fluid from the base end of the boom cylinders and allow the boom to lower with the engine on or off. And here's just a few other shots of the inside of the cab. Of course, you have the seat belts, the lap bar, rear window with emergency exit pull tab, some dangling wiring, The fuse panel is behind this cover. These are not sealed up very good, and it's a somewhat common problem for moisture to get in and corrode them and cause strange electrical problems. I've removed the hood off the back of the machine. That just lifts up and out very simply. And now you can see the cooling stack. So right on top here we have the hydraulic oil cooler. That will hinge up out of the way a little bit, hopefully allow you to see the engine oil cooler, which is underneath it. It should be noted that if you have air conditioning, there will actually be an air conditioning condenser on top of the hydraulic oil cooler, so that will be the first thing you see. This hose here is just the air intake hose. Underneath the engine oil cooler, there is a large squirrel cage blower that is belt driven off the engine that pulls air down across the radiators and forces it out either side of the machine through these grates. Yeah, so there's the fan blades, and then hopefully you can make out the fins on the underside of the engine oil cooler there. Opening the back door, we can see into the engine compartment. We have the muffler, and then directly below that we have the engine. There is a data plate on top of the valve cover on the engine, but you can't see it because it's hidden by the muffler. But the 873G, along with all other 873s and 863s, is powered by a Deutz BF4M1011F. It is a 2.9 liter 4-cylinder direct injected turbocharged diesel engine that is rated to produce 73 horsepower at a maximum speed of 2350 RPM and has a maximum torque output of 176 foot-pounds or 238 Newton meters at 1800 RPM. As I alluded to, this is an oil-cooled engine, so the lubricating oil is also circulated around for cooling. There is an externally mounted oil pump right here that is driven off the timing belt and provides flow both for lubrication and cooling. It pumps oil up into the cooling jacket here and also up into the head and to lubricate the rocker arms. That oil flows across into the thermostat housing, which is right here. If the oil's hot and the thermostat is open, it flows out through this hose through the oil cooler and then returns via this hose into this fitting here and then flows internally back to the oil filter here. And then of course if the thermostat is closed and the engine's cold, it bypasses the oil cooler and flows into the filter housing here. From the oil filter, it then flows into the rod, main, and camshaft bearings, and then of course back into the oil sump. These plugs and fittings here are a series of relief valves which are designed to maintain oil pressure on the rotating group while also allowing for oil flow out to a heater core. This is a relief valve, this is flow out to a heater core. This one you can't really see right under that is another relief valve, and then this bottom one is return from the heater core, and it also has yet another relief valve built into it. Here you can see the individual injection pumps. There's one for each cylinder. They are driven off the camshaft, and then the injection lines go up to the injectors in the head. Directly underneath each injector there is a glow plug. It's kind of hard to see. As I mentioned, this engine uses a timing belt to control the camshaft timing and drive the oil pump. Bobcat recommends replacing it no less frequently than every 3,000 hours or 5 years. However, it is relatively common for people to run it well over that interval and actually to the point where the timing belt breaks. It is an interference engine, so when the timing belt breaks, the valves can contact the pistons. But fortunately, usually when that happens, the damage is limited to bent push rods because the bottom of the valve is in the same plane as the top of the piston. So the valves don't come in at an angle, they come in straight up and down. So usually the push rods are the weak link and they bend instead of the valves, and you can replace those with the engine still in the machine and get yourself back running. Of course, you have the oil dipstick, fuel transfer pump, fuel filter, starter, obviously. That's an aftermarket electric pump that someone installed. Engine oil drain. You can kind of see the oil pan there. Underneath the oil pan, there is a plastic tank for fuel, and there's the engine speed sensor there. Air filter, of course. And behind this large plastic cover is the pump drive belt, so let me slip that off and show you that. That's just a matter of popping those clips off and sliding the cover out the back. But with that out of the way, hopefully you can see the drive belt here. So this belt powers the hydraulic system off the engine crankshaft. You can see the tensioner there. And then the crankshaft pulley, the cooling fins on it. But at this point, I'm going to take some access covers off and lift the cab up so I can show you the rest of the inside of the machine. Alright, I've got those covers opened up. Now to raise the cab is extremely easy. You just take the nuts and washers off of these two threaded studs in the cab corners and then just pick up on the front of the cab. And then this strut here has a little locking tab on it that holds it up once it gets past a certain point so it can't come back down on you. I do want to stress that you do not need to raise the boom in order to raise the cab. I just did that to give myself a little bit better access. You can absolutely raise the cab with the boom all the way down, which is something I really like about these Bobcats. So in this left-hand side access cover, you can see the drive belt for the cooling fan there, the tensioner, input for the cooling fan gearbox. You can see the other end of the pump drive belt down there. This is the control valve for the rear auxiliary hydraulics, which this machine is actually equipped with. Through the access panel on the right-hand side of the machine, you can see the turbocharger on the back of the engine, the gear pump. That large spring is the centering spring for the drive controls. You can see the back side of the drive pumps there, and the top of the fuel tank down there. We have the hydraulic oil filter. This is the hydraulic temperature sending unit. And then kind of hidden on the back side of the filter head, there is a pressure switch for the hydraulic oil filter restriction warning light. You can see the plastic fan housing. This is the fan drive gearbox, so there's the drive belt, and then there's a drive shaft that runs through there to a bevel gear, and then it goes up, and the fan is mounted on that shaft there. The 873G uses a Sauer Sunstrand, or Sauer Danfoss, M44 tandem hydrostatic drive pump. It is a variable displacement axial piston pump with integral charge pump. So there's a drive pump here and a drive pump there, and then sandwiched in between them is a little charge pump. Rather than being servo controlled, the M44 uses direct displacement control. So when you stroke the control lever for drive, it moves this crank here, which is attached to this rod, which goes all the way back to this T-shaped aluminum piece on top of the pump, and that is bolted to the trunnion shaft. So as you move it, you are physically moving this wash plate inside the pump, and then centering is accomplished by this spring on the end, which compresses if the handle is moved in either direction. And it's the exact same setup on the other side here. That one's a little bit harder to see, but if you stroke the lever, it moves that plate on top, which compresses that spring on the end and pushes it back towards center. It's pretty common for these bushings on the end of these T-shaped pieces and elsewhere in the linkage to wear out, and then your Bobcat won't want to return to neutral. It'll kind of have a mind of its own. It's a relatively straightforward job to get in there and just unbolt all that stuff and replace all the bushings and get it back working good. There's the gear pump again, mounted directly to the end of the tandem drive pump. That of course supplies fluid for the boom, bucket, and auxiliary hydraulics. If you have a high flow machine, there will be actually a double gear pump. It can be aluminum or cast iron, depending on serial number. Here's a look at the tag on the pump. The MPT 044D identifies it as a M44 pump, and then that long string of numbers afterward can be decoded into all like the options that it came with from the factory, input shaft, output shaft, seal options, paint, etc., etc. In the event that you need to tow the loader, there are some bypass valves that you need to loosen in order to allow it to freewheel. They are impossible to see. I'll try to find a picture of them so you can get a better idea of where they are. But there's 4 of them. There's 2 on top and then 2 underneath. They have a 5/16 Allen head hole in them, and they just need to be loosened no more than 4 turns maximum. And doing that will allow the fluid from the drive motors to bypass through the pump uninhibited. The other thing that you'll need to do if you want to tow the machine on a single speed machine like this is to either energize this solenoid for the parking brake, or you can just remove it. It's super easy. It's just 2 bolts down there on either side, and then it just lifts up and out, and you'll see there's a little mechanism in there that has like a locking block that slides up and down into slots in discs that are mounted on the drive motors. And when the solenoid is disengaged, the block slides down into the slots in the discs and locks the whole mechanism up like a stick through a bike wheel. 2-speed machines are a little bit different. There is a parking brake integrated into each drive motor, and it is spring applied and hydraulically released. So what you do is, instead of this solenoid mechanism here, there will be like a valve block, and there's one solenoid that will have like a little knob on the end. You push that in and turn it, I think, counterclockwise, and that opens up the valve, and then you connect like a handheld hydraulic pump, like a porta-power pump, and pressurize it to about 400 psi to relieve the brakes on the wheel motors, and then they will turn. In any case, Bobcat says not to tow these more than 25 feet at 2 miles an hour. So it's more like on and off a tow truck, in and out of the shop, that kind of thing. You wouldn't want to like tow it down the road or anything like that. Here you can see the control valve for the boom, bucket, and auxiliary functions. There's kind of a lot going on there, so I'll just post a picture that describes everything. However, that picture shows the valve with the Bobcat interlock control valve already removed. so it's pretty difficult to see, but there's actually a valve bolted onto a valve is what you're looking at here. So you've got like these little 7/16 bolts. I think there's some over here, there, and there. And then, so you unbolt that, and then you have the rest of the control valve, and that's what the picture is showing you. But these solenoids activate the auxiliary hydraulics, which are the topmost spool, and then right below that in the middle is bucket tilt, and on the bottom is boom, raise and lower. You can see the mechanical linkages attached to the end of the control valve spools for the boom and bucket. There's one that goes straight forward and attaches to the right hand foot pedal, and then the one for the boom comes across, pivots at this linkage here, and then attaches to that linkage bar there that goes up to the left hand foot pedal. If your machine has advanced hand controls or advanced control system controls, the valve will look very similar, but in place of those mechanical linkage bars, there will be some big like electrical actuators that move the spools. That silver cartridge there is the case drain filter for the drive motors. I'm not sure why, but the manual for this machine shows it having two case drain filters kind of tucked down away behind each drive motor, one on each side, and for whatever reason in real life this machine just has the one there. So yours may be in a different spot, but that's what they look like, at least if you're trying to find them. Here you can see the right hand side drive motor. It is a Rexroth MCR5 low speed high torque hydraulic motor. They are radial piston motors, so there is a lobed cam ring mounted around the circumference of the motor, and then there are a bunch of little pistons that travel parallel to the radius of the output shaft. As they are forced up and down by hydraulic pressure against the lobes of the cam ring, they force the whole assembly to turn. These motors have an integral flushing valve, which is mounted behind this plug here. That automatically takes hydraulic fluid from whichever side is the low pressure side of the circuit and drains it back through the case drain into the pump and back into the reservoir to be recirculated. And that's just done to keep a little bit of fresh fluid circulating into the closed loop to keep it clean and keep it from overheating. This is a single speed machine, so it just has input and outputs, and then a case drain line in the middle there. The two-speed machines look quite a bit different. They have an integral parking brake that is bolted on to this. You can't miss it. It looks like the head of a drum, and they will have several additional lines for parking brake, two-speed activation, and I think something else I can't remember. You might just be able to see that light down there. That is a drain hole. There's one on each side, and that's how you're intended to drain like water out if you're washing the machine out. Through the right-hand side access cover, we can see the right-hand drive motor, which is identical, and also the hydraulic fluid drain line, which just kind of hangs out in here. The computer is also located on the left-hand side, kind of hidden up under everything behind right here. These bolts hold it on, but it's actually relatively easy to access if you take off this panel from the inside of the machine. And this little access plate underneath the back of the machine can be removed to drain the fuel tank and I think the chain case. And then at the very front of the machine is the fill hole for the chain case. But anyway, that covers pretty much everything I can think of to tell you about the 873G. I apologize if there was anything specific that you were looking for that I didn't cover. I'm sure there was stuff that I meant to cover and forgot about, but if you have any questions about it, just leave me a comment, and if I can't answer it, maybe someone else can.